Hey everyone, my name's Charles Machin. I'm going to be doing a quick rundown on how to do agent processing in the Blockgen.art Construct platform. So what is an agent? An agent is an autonomous entity that can exist on the canvas. It has, well, at least the ones that we're going to make here, have a position, velocity and scale, though they can technically have as many values as you want on them. They are extremely useful to create lots of drawing operations that all happen in parallel. So let's just get straight into this. So first off, all of my agents are going to live in an array. So I'm going to make an agents array. So there we go, there's our new agents array. Next, I'm going to populate this agents array with agent objects. So I'm going to make one of the compact for loops that's present in the Blockgen.art platform. So that is for with a capital F at the beginning, and it's a function, so we call it with brackets, and it goes from 0 to 100. So I want to do a for loop, 100 cycles, and then we put in a pointy function in for the individual steps. So I want to add to this agents array, so agents .push, which adds an item, and we want to add our agent. So what is our agent going to be? Our agent's going to be another array, but with 3 values in it. It's going to have a velocity vector, it's going to start with a position vector, a velocity vector, and a scale vector. So to create a vector in this platform, it's capital V2, so a vector 2. So I'm going to put a vector 2 in 3 of those places. So this is our position, that's our velocity, that's our scale. So first off, for our position, I want these agents to be scattered in a circle all the way around here. So in order to do that, I want the transition and iteration values for this for loop. So in order to do that, in the pointy function, I'm going to have an n, which will be the cycle number, and a t, which will be the 0 to 1 transition value. Now, these values get automatically populated by the for loop, and so this is basically all you have to do, and I've now got a transition value. So first off, I want this vector 2 to be a circle around the center. So I'm going to start with a circle. So the function is circ, and I want to use tau. So tau is the number of radians. So circ takes its value in radians. Tau is the number of radians for a perfect circle. So it's like the equivalent of 360 degrees for a full rotation. And I want to just multiply that by t. So now, as this for loop goes around for its 100 steps, it will start at the beginning of the circle and work all its way all the way around. Now this circ function outputs vectors at 1 length. So on this canvas there's 1000 by 1000 pixels. So that's not a very big circle. So first off we want to multiply it. So I'm going to put a dot more on at the end of that vector, and I'm going to multiply it by 400. So it's going to be a 400 pixel circle. Right now this is originating around the 0, 0 point, which is over here. So this circle will actually be like this to the corner of the canvas. So I want to move it to the center. So in order to do that, I'm going to increment the both components of the vector by 500, which is halfway through the canvas. So now we should have a circle that's a full circle here. Next, for the velocity, I'm going to just keep this really, really simple. I'm going to put a 0 in and a 1 in. So left and right, no movement. 1 is down on the canvas. And then for my scale, I'm just going to have 1, 1. You can just have a uniform scale of 1. So next, I want to make an integrate function that takes my array of agents and adds the velocity to them. One step. So let's go, let's integrate equals, we want to give it the agents. So we pass in the agents, and then it does an operation on all of the agents. So for this, we're going to use a compact for each loop. So JavaScript arrays have a for each loop already built in. You do it like this, agent start for each, and then you put a pointy function in where it would be like agent, and then you do something. The Blockgen way of doing this is a little bit more compact. You go FOE, so capital F, small o, capital E, for each, and then we put in the agents, and then we get the agent, and we get the iteration value, what agent number it is in the array. So that's versus that. Okay, so next, I want to unpack agent into its components. So I'm going to go let's position, so P, V, s, so position velocity scale equals agent. So what that does is that unpacks 3 separate variables and declares them, PV and S, and it unpacks the agent array and puts them in there. Super convenient and extremely compact. And so all I need to do now is go P, so that's the position vector, dot add V. Oh. Change the scaling. Yeah, add V. So that is actually all that's needed for an integrate. That integrates 1 step for the agent. So that technically means that they can move. So next we want to be able to draw all of these agents. So let's make a draw function. So let draw equals, takes in agents as its argument. And then I'm going to just yoink this because I want nearly exactly the same, but without the add part. So now we're going to go through all of the agents that are passed in and extract their position, velocity, and scale, and now we're going to draw them. I'm going to draw them with the rect function. So I'm going to draw them with black. I'm going to do p.x, p.y, comma s.x, comma s.y. So that, with these two functions, that should allow our agents that are distributed in a circle to move downwards based on the velocity that we set here. That should be pretty straightforward. So let's see if that works. So if I just integrate my agents, and then I draw my agents. Okay, there we go. Let's see if it works. So there we go. We've now got agents drawing and moving down the screen. Okay, so next, let's make it so that the agents vary their direction each cycle so that they can turn a little bit left or a little bit right on every single cycle. So ultimately, they're going to make wiggly lines. So let's make that happen. So I'm going to make another function. Let random turn equals, we're going to take the agents in again. We want to iterate the agents exactly the same as we did in the integrate. So I'm going to put my for loop in here, and we want to, on the velocity, we want to extract the direction that it's facing in radians. So let rad equals v.rad. So that gives us our the radian value of that 2D vector. I also need the length, just to keep it consistent. Let len equals v.len. So we now know both the length and the radian direction of that vector. And then on the radian value, I'm going to add a random value, so rn. So that uses our random number generator, rn.f. And I want it to be minus 0.01 to 1. So plus and minus 0.1 radians. And then we want to put that value back into our velocity vector. So v.circ rad dot, we want to multiply it by the length. So we've now got that. So if I put that into our draw and our agents like that, let's see if that works. Okay, so now we've got some wiry hair-like agents, extremely rough-looking ones. So these agents, they don't have a lifespan, they will just keep going forever. They're also not constrained to the canvas, so their values can go way, way off the canvas where they can't even be drawn anymore. So they're pretty wild agents, these ones. So we up our for loop on our creation count to, let's say, 1,000. That's what 1,000 agents look like, or even 10,000 agents. High numbers of agents. 10,000, they take a little bit longer to compute, so you can see that the frame rate is a little slower. Wiry shading. So let's give our agents a lifespan. So next, if I go let, so basically a lifespan is we just want to kill them after a certain number of steps. So if I go kill, and we take in agents and the lifespan. So the trick here with something like a kill where we're actually removing agents from an array is it's best to iterate the array in reverse rather than forward. Let's do a for loop. We want the for loop let n equals the last index, so we want agents dot length minus 1, and then we want to go n is greater than 0 because we want it to, is greater or equal than, greater than and or equal to 0, and then we want to go n minus minus, go the way backwards. Okay, so first off we want to unpack our agent. Take that, so we have to declare our agent. So let agents equal agents n. per agent, and then we need a life value. So we don't actually have a life value in here, so I'm going to go p.life. So I'm going to actually just pin it onto our position vector equals p.life. So basically equals itself, or if it doesn't exist, it equals 0. So this initializes it to 0, and then we want to increment the life value. And then we want to ask the question, if p.life is greater than the lifespan, we want to kill it. And we do a kill it by going agents.splice, and we give it the index of the one that we want to remove. So that's the index is n, and we want to remove one item. So now if we add this kill agents, give them a life of 200 cycles. So that's 200 frames that they'll cycle, and then they should stop. Let's see how that. Ah, there we go. They stopped. Nice. So if we want these agents to fade out towards the end, we want to basically use a value that's almost created as part of the kill. So if we, so p dot, I'm going to use age. So age is going to be a 0 to 1 value. And I want it to be lifespan. So p dot life. Lifespan was the other way around. Oh, lifespan. No, I think it's the other way around. Divided by p dot life, and then we've got a p dot age that's there, and we can use that to modify our. So let's scale age equals p dot age, and we should be able to just multiply that to these. So this will result in agents that start small and end big. Huh. Maybe these are the wrong way around. Ah, there we go. So now we've got agents that grow as they get older. So let's have a little bit of fun with this. So at the moment we're just using a circle. So let's increase the number of agents to 10,000 agents, and let's make it a spiral. So if you remember, this is our position, and we're making it as a circle based on this loop, and we're multiplying it to make it a radius of 400. So if we multiply that by a t value, that will mean that it starts at 0 and it gradually comes out. So basically we'll end up with a spiral. And if we want to do a couple of revolutions of the spiral, we can multiply this part by 2. So now we end up with an interesting fluffy spiral of some kind, which is a bit of fun. Okay, well, thank you very much for tuning in. I hope this tutorial is useful, and you can find this project in our examples page. I'll comment this up to make it a little bit more straightforward. And thank you very much for listening.